Okay, graphing logarithmic functions. Okay, so for the logarithmic functions, it's kind of a lot like the exponential functions. I mean, they're inverses of each other, so it makes sense that they're a lot alike. But if a is between 0 and 1, that's going to be the exponential, or it'll be a decay. And if a is greater than 1, then it's going to be strictly increasing. Okay, and let's just go through some examples here. So if we have log base 2 of x, well, we need to figure out how to graph this. How are we going to graph this thing? So why don't we pull the old switcheroo? Let's change this to an exponential. So f of x we can just say is y. That's the same thing as 2 to the y power equals x. Okay. So now this is in terms of y instead of x. So I'm going to do the negative 2 to 2 for my y values instead of my x values. Okay, which makes sense because exponentials and logarithms are inverses of each other, so we would do the opposite, essentially. So if I plug in 2 to the 0 power is 1, 2 to the first is 2, 2 squared is 4, negative 1 is 1/2, and negative 2 is 1/4. And then we can graph it. Now we can graph it. So it would be 1/4 negative 2 is right there. 1/2 negative 1, 1 0, 2 1, and 4 2. Boom. Which that looks a lot like the exponential graph. The exponential graph would be right here. Okay. One thing with inverses, they always can be reflected on that line right there. We're going to have a unit on that, but it is some knowledge that's kind of cool to know. Okay. So let's see. Now the domain here, 0 to infinity. Range is negative infinity to infinity. Now, end behavior. So the left end of this is going towards 0, which is why we have x goes to 0 here. So as x goes to 0, f of x is going to negative infinity. And as x goes to infinity, f of x goes to infinity. Our x-intercept is 1, 0, and our asymptote is x equals 0. Cool? Let's do this one. So this one's going to be strictly decreasing. So switcheroo, this is going to be y equals log base 1/2 of x. So that's 1/2 to the y power equals x. And then I'm going to put negative 2 to 2 for my y values. So that's going to be 1/2 to the 0 is negative 1. 1/2 to the first is 1/2. 1/2 squared is 1/4. To the negative first is 2. And to the negative second is 4. So then 4, negative 2... 2, negative 1, 1, 0, 1/2, 1, and 1/4, 2. Oh, I did that wrong. Whoopsie. This is the wrong point. It should be right here. Okay, just pretend. So then that looks like that. So then this is going to be domain is 0 to infinity. Range is negative infinity to infinity. And behavior as x goes to 0, f of x goes to infinity. As x goes to infinity, f of x goes to negative infinity. X-intercept would be 1, 0, and asymptote would be 0. X equals 0. Okay? All right, let's do transformations. That's so stupid. I put the stupidest things on here sometimes. Okay, so a log base b of x minus h plus k. So a is our vertical stretch or compression, just like on the exponential ones. So if it's greater than 1, it's a stretch. Less than 1, it's a compress. H is the horizontal translation, opposite of what you think, and not V. K, this is a K. I was struggling when I made this, I guess. K is a vertical translation. Okay? So on this one, log base 4 of x plus 3 minus 9. The parent graph is log base 4 of x, and the transformations are left 3 and down 9. This one, parent graph would be log base 1/2 of x. The 3 would be a vertical stretch by 3, right 4 up 2. This one, parent graph is log of x, vertical compressed by 1/2, left 7, down 3. Okay, and we're going to graph these pretty much the same way as the exponentials, where we draw like the other graph or the lines. Okay. So log base 1/3 of x plus 6 equals, or plus 4. So the parent function is log base 1/3 of x. And this moves left 6 and up 4. So if we go left 6 and up 4, there's that. So that's going to be like our new origin point. So I'm just going to look at the log base 1/3 of x. Switch that to an exponential so we get 1/3 of y equals x. And then I can plug those all in, and we end up getting 9, 3, 1, 1/3, and 1/9. So then we can graph these from here. So 9, -2, but I'm going to go from this point right here. This is our new origin that we're working from, okay? So 9, -2 is right there. 3, -1, 1, 0, 1/3, 1, and then 1/9, 2. Gosh, and I messed that up again. What is wrong with me? Right there. Sorry. Okay. I'm gonna graph that. Now, our domain here is -6 to infinity. Our range is -infinity to infinity. And behavior as x goes to -6, f of x goes to infinity. And as x goes to infinity, f of x goes to -infinity. Now, the x-intercept here, we need to know how, where I skipped it. Asymptote is -6. Let's go back to the x-intercept. So x-intercept is where y equals 0. So I need to put 0 in on the left side, and then I have to solve this log equation, okay? So I'm going to subtract the 4 over, switch that to an exponential, so I get 1/3 to the -4th power equals x plus 6, which that's 81 equals x plus 6, so x equals 75. So really, this isn't touching the x-axis until like way down there. Okay. Let's do another one. So this one, our parent function is log base 5 of x, and our transformation is right 2 and up 1. So right 2, up 1. So we have just our parent function we're looking at, so that's 5 to the y power equals x, which if I put that on our table, we have 1/25, 1/5, 1, 5, and 25. So then 1/25 -2 is right there. 1/5 -1, 1, 0, 5, 1, and then 25, 2 is going to be off our graph. So that's going to be what we draw. Domain is 2 to infinity. Range is -infinity to infinity. And behavior as x goes to 2, f of x goes to -infinity. And as x goes to infinity, f of x goes to infinity. Asymptote is x equals 2. And then to find our x-intercept, you have to solve this log equation. So subtract the 1. 5 to the -1st power equals x minus 2. So it's 1/5 equals x minus 2. Add the 2, and you get 11/5. Cool? Goodbye.